Hi guys, so this is the ambiguous case of sine law. This is a little different from the regular sine law and the cosine law. This is actually, sorry, this is just an application of the sine law. It can be a little difficult, so pay attention to the video when you're watching this, okay? So when you're dealing with the ambiguous case of sine law, as you can see from the title of it, we're trying to investigate the ambiguity of a triangle, whether the triangle can be formed in a different ways rather than a conventional way of forming one. So when you're forming a triangle, usually you can form a triangle by having two sides and a one angle. Okay, that angle is one of the opposite angles of the given two sides. Okay, now in order for us to investigate this, we need to remember two things that we learned in the past. The first thing is two different angles can give the same sine ratio. Okay, one example can be sine 45 is exactly the same as sine 135, and that is actually square root of 2 over 2. Now, if you're not sure why this is, you have to go back to the previous lessons, okay? This is literally the key of the whole concept here, okay? Then the sine ratio can only be from -1 to 1. It cannot be -2, it cannot be 3, it cannot be 3 or 4. It has to be in between -1 and then 1, okay? Now, then there are three cases. So the first case is that it forms a two triangles. So how that works is this. So what I'm going to do is I'm going to draw an acute angle triangle. Okay, this kind of looks so I'm going to draw a little differently. So let's say I draw more like this. Now, this is an acute angle triangle. It's not a right angle triangle, even though it looks like. Now, and it's still not a good drawing. Okay, so here's the better drawing. There we go. So if I have formed this triangle, which is an acute triangle, what I can do is I can actually swing this arm to this way, right? I can swing this way. Now, then what happens is you actually have an obtuse triangle right here, right? You can see it. Now, that happens when you have two triangles. And that happens when your angle here, I'm going to call this one angle B for now, and then this one is angle A. The B angle that you find from the sine law is an acute angle because I can simply swing the arm and then I can form this obtuse triangle, the red one, right? So this is the case where your B, the angle B, is an acute triangle or an acute angle. Okay. Now then you're going to ask me, but what about the arm being in the middle here, making a straight line? Well, the thing is, if you actually construct using three pencils-ish, this part will actually pass the baseline. And that we don't really say that's a perfect triangle because there's unused material, right? So we cannot really do that when you have an acute angle, okay? Now, then let's take a look at the right angle. The one triangle. Now, the one triangle, if I form this triangle, let's say I'm going to call this one as a straight line down to the base, which forms a right angle triangle. Now, if you try to swing this, let's say I'm going to swing this arm this way like this, okay? What happens is this arm actually is shorter. Not shorter, but it's short to meet the base. So it doesn't really meet the base. So it doesn't form the triangle. And then another way is if I have a longer base here, if I rotate or if I push this arm to this side, same thing happens because this straight down line only meets at one point in terms of the baseline, right? Because you have to swing it. You have to swing it. Just to remind you, if I had the arm like this, it swings at this trajectory pretty much. Therefore, the line in the middle actually is shorter than the lines on the side. Therefore, if the line actually meets the base at a right angle, then it means that that's the only point where the line is going to meet the base. Then it forms a right angle triangle. So when the angle B, I'm going to call this one angle B again, and then angle A here again, is a right angle, then there's only one triangle, okay? Now the last one is obviously no triangle. Now the no triangle is this. So here's the base, here's the arm that was given to us. Now, if the arm is short, right? If the arm is short, it's not going to form a triangle. Well, what if the arm is longer, like this? Well, all I can do is I can kind of shift to this way or rotate it this way so that it will somehow meet somewhere further, right? But if you have a shorter arm like this, or let's say even like that, if I swing it, it's not going to meet. Okay, it's not going to meet at one point. It's not going to meet here, or it's not going to meet there. It's way short, meaning there is no angle B, right? There is no angle B. So when angle B does not exist, or your calculator will say error on the screen, then there is no triangle. Okay, so let's do an example of this. So when the example says information, it gives you the angle A as I drew in the figures on the case 1, 2, and 3, and then it's going to give you the two side lengths. So the angle A, let's say, is 30 degrees, and then the side A, which is the opposite side of the angle A, is let's say 10 meters, and then side B is, let's say, 5 meters. Then it says how many triangles does it form, and what kind of triangles are they with what angle. So how many triangles? Now then all you have to do is this. The baseline is always just a long. Okay, we don't really care about the baseline. Okay, we really don't care about the baseline. So just draw a somewhat long line. Now the angle A will be formed by this terminal arm. So I'm going to call this A, and we know that that is 30 degrees. Now B is then formed by another line, B here, and then the side A is the opposite of the angle A, so that's 10 meters, and then side B is the opposite of the angle B. Now, as we saw it in the three cases, as long as we know what angle the B forms, we know that how many triangles are formed. So all our job is to find what angle B is, okay? So that's basically the key of it. Now, in this case, we have an angle, and its opposite side known to us. So all we can do is we simply create the sine law. So we have sine 30 degrees over 10 equals then sine B over 5. Now, sine 30 degrees is 1 over 2, and then you divide it by 10, so it's 0.05 then, times 5, because we have to multiply this 5 to isolate the sine B. Then this gives me 0.25 equals sine B. Now, then in order for us to find what the B is, we have to use the inverse function of the sine in this case, since we're looking for the sine. So we're looking for the angle of with the sine ratio. If you're looking for the angle with the cosine ratio, obviously you have to do it with the cosine ratio. So then in this case, we have B equals sine inverse of 0.25, and that gives you the angle of 14 point, let's say, 5 degrees. To be exact, it's 14.4775, etc., etc. I just rounded. Now, 14.5 degrees is an acute angle because it is in between 0 and the 90. So, therefore, there are two triangles. Then the question is, what about the other triangle? Well, I'm going to use the blue to figure out what the other triangle is. If I swing this, then it's going to form another line right here. Do you agree? So I'm going to label that as B prime, that I moved B, or I shifted B. Now, I know that this side then is exactly the same as this side. This is isosceles triangle then. Then this is 14.5 degrees too. So the triangle that I'm going to highlight in blue is the obtuse triangle with the obtuse angle of 180 minus 14.5. So the angle, let's say B prime here, is then 180 minus 14.5, which is actually just the angle B, and that gives me, let's see, 165.5 5 degrees, if I didn't make a mistake in the calculation in my head. So you have two triangles. One is a large acute triangle that has the red angle, and then the other triangle is the blue highlighted triangle, the obtuse triangle, that has obtuse angle of 165.5 degrees. So hopefully this is easy to understand. Okay, I took up this already in the class, so hopefully you watch this and then bring more questions to me in class. Okay, so see you guys in class. Bye.